In this video, we are going to take a look at integrating using substitution rule. Now, this specific integral is kind of tricky. That's why I wanted to go over it. We've got 7 divided by square root of 9 minus x squared dx. Okay, now the idea here is that what you want is to convert your integral to something that you already know and memorized from before. You might or might not know that one of the integrals that we calculus teachers always want our students to know is this basic integral of 1 over square root of 1 minus x squared, which is actually arc sine x. So don't worry if you don't know that, but this is just one of those that you have to memorize. Now, this particular integral that I'm trying to do is not the same because it has a 9 instead of a 1. So we need to do some algebra. Let me show you what we could do to make it look like the one we know. First of all, that's 7, though. It doesn't make any difference. We can just pull it out and multiply by it at the end. And so this is what I get, 1 over square root. Now, because I want, instead of that 9, I want to get a 1, here's the trick. I'm going to factor out the 9. Okay? When you factor out the 9, what will happen is the first term is going to be 1, right? Not 0, because 9 times 1 would be 9, right? Minus, now the x squared does not have a 9, so to compensate, you want to divide by 9, right? This way, if you multiply 9 times x squared divided by 9, 9 is going to cancel and you're going to wind up with the same thing. Okay, so far I did not do anything other than just rewrite that bottom to make it look a little bit more like 1 minus something. Now that something has to be a square, right? In order for it to look like 1 minus x squared. It's not going to be x, it's going to be u, but you still want to make it look like the one you know. Okay, let's see if we can do that. First of all, we can split. Whenever you have a product under the same square root, you can just split it into the square root of the first factor multiplied by square root of the second factor. Now, with the second factor, that x squared divided by 9 can be written as x divided by 3 squared. Okay, why is that? Because when you distribute the squared, you get x squared and 3 squared, and that's 9. Okay, so far I have not done anything other than just rewrite my integrand. My next step is to actually do the substitution. And what we're going to do is try the substitution u equals x over 3. Again, why? Because we want our integral to look like this, because we know what it is. And if I say that x over 3, this thing right here, is u, then I'm going to get 1 minus u squared on the bottom. Okay, let's do that. So we got 7, then the integral. Okay, instead of square root of 9, I'm just going to put 3. And then here I will get 1 minus u squared. And people frequently, especially if this is the first time that you are introduced to the substitution rule, people frequently just think that this dx doesn't matter, that we're just going to automatically change it to du. But that is not right. Actually, dx and du are not the same. What is the connection? Well, you have to go back over here and you have to think, okay, what is u? U was x over 3. If I find du, what does that mean? Well, this is actually differential. What is the difference between differential and derivative? Derivative is you just take the derivative. Differential, you don't just take the derivative, but also multiply it by d something. And the something is whatever the variable that you're taking the derivative of. So if you're integrating, I'm still in the calc 2 mode. If you are differentiating with respect to x, then you're going to be multiplying by dx. But how do I take the derivative of x divided by 3? Here I'm going to do a little trick. Instead of dividing by 3, I'm going to multiply by 1/3. So this will become 1/3 x. And now, when you take the derivative of number x, that's just the number. And that means I'll just get 1/3. And x, well, derivative of 1/3 x is 1/3. And then you have to still multiply by the dx. Again, why? Because this is differential, not derivative. So you still have to have that dx. This is so important because now this relationship is going to allow us to see the difference between dx and du. Okay, in order to solve for dx, I want to isolate it. I want to have it by itself on one side. And normally I would tell you to divide by 1/3, but I don't want to divide by 1/3 because it's easier to actually multiply by 3. What I will do is just multiply both sides so I don't change the equation. So I'll multiply this by 3 and here by 3. And what that does is it's going to cancel that 1/3 and 3, and I will get 3 du equals dx. Okay, so now I know that dx is really not just du, but 3 du. Okay, so instead of this, I'm going to put 3 du. The next step to notice is that the 3's are going to cancel. So you can go ahead and cancel the 3's. And now our integral is just like the one we know. This one right here. We know what that is. Now we are ready to integrate. Okay, let's do that. 7 stays 7. And then the square root 1 minus u squared, which by the way is not 1 minus u. You cannot separate the square root. You can only do that when things are multiplied or divided. If things are subtracted, those are not factors, and square root of a difference is not difference of square roots or something like that. That does not work. And in fact, it just becomes arc sine u, and then plus c. The last step here is to remember, okay, what was it that I was calling u? Because you cannot leave the final answer in terms of u. You have to convert it back to x. And u was x over 3, which means that this is going to be arc sine x over 3 plus c. Okay, so this is going to be 1/3 dx. Then this becomes 7. And then I already showed you guys that will just, the 3 and the 3 cancels out. And I will just get square root of 1 minus u squared. This becomes 7 arc sine u. And now all I have to do is plug in the whatever u was, which is x over 3. And I am done.